you got a one-way ticket to Mars, would you go? You might get the opportunity to in your lifetime. That's pretty exciting. But anyway, NASA's revealed a possible vehicle to travel over the Martian surface. Mars is dusty, great, and it has a lower gravity than ours. Around 3.7 newtons per kg on Mars compared to approximately 10 newtons per kg on Earth. Right, and here's our rover. Looks a bit like a tank. I don't know how to draw a Martian rover. Maybe it has a little robot arm to pick up soils. Okay, it looks like a sink. Anyway, define mass and weight. Awesome. Mass versus weight. So, what is mass? Let's start with that. Mass is the amount of stuff, right? Or the amount of matter in an object. And what is it measured in? It is measured in kilograms, right? In kgs. So when you go to the grocery store and like things cost, I don't know, $4 per kg, that's per mass, right? Per unit mass. Whereas weight is related to mass, but weight is the effect, or the force is the effect of gravity on an object that has mass, right? But that's assumed when we say an object, and that's measured in newtons, right? Capital N for newtons. So, for example, I have a weight of about 680 newtons, and that corresponds to a mass of 68 kgs when I'm on Earth. All right. Now explain what 10 newtons per kg means. Well, that is 10 newtons per kilogram. Just putting it into words. But what does that mean? So for every 1 kg of matter, there's 10 newtons of force acting on it. So for every 1 kg, there is 10 newtons of force acting on it. So going back to the example I just used with my mass, if I have a mass of 68 kgs, that will correspond to a weight force of 680 newtons, because for every 1 kg, there are 10 newtons of force pulling me down into the center of Earth. Right, so for every 1 kg, there's 10 newton force acting on it towards Earth's center. Or you could say the surface, that's fine too. Right, so on Earth, we have this acceleration due to gravity, or this pull downwards of 10 newtons per kg. Next question. Right, now we're calculating some weight forces. So of the vehicle when it's on Mars and when it's on Earth. So the weight force is equal to the mass times acceleration due to gravity, or mg, mass times gravity. So when it's on Earth, the weight force is its mass, which is 2,500 kgs, times g, which is 10, giving us a weight force of 25,000 newtons. All right. Now, part 2, when it's on Mars, The only difference here, the mass is the same. However, G is 3.7. So its weight force is 9,250 newtons, just rounded to 3 significant figure. And so looking at those, the weight force on Mars is less than it is on Earth, even though it has the same mass. Okay, so there are 6 wheels on this vehicle, and each wheel has an area, a surface area in contact with the ground of 0.25 meters squared. Right now, let's say they're going for a test run out somewhere, maybe your mate's farm, right, on some soil. What is the pressure that this vehicle exerts on the ground? Cool. So we know pressure is equal to the force divided by the area. So the force downwards on the ground divided by the contact area. And so what would the force be? Well, a beautiful rover thing. The force on Earth acting downwards is just the weight force. And we just worked out the weight force of this vehicle is 25,000 newtons. So that's the force acting downwards. And the contact area of this vehicle, well, one wheel is 0.25 meters squared, but there are 6 wheels in contact with the ground. So the total contact area would be 6 times 0.25. What is that? That is 6 times 0.25, 1.5 meters squared. And now we can substitute in our values. So for force and for area. And with that, we can then work out the pressure. So pressure equals the force divided by the area, which equals 16,667. And then the units for pressure, what are they? They could be newtons per meter squared, or more commonly, pascals. And so the rover exerts 16,667 pascals of pressure on Earth, right? Assuming it's just on the ground, laying flat. Final question, question E. All right, assuming that on Mars and on Earth, we can put it on like the same type of soil, right? They're equivalent soils. Why will the Mars vehicle, why will that sink to a different depth on each planet? Okay, so we have our rover. This is one on Earth, let's say. And then our rover on Mars. They're going to sink to different depths in the soil. And how do we know which one will be deeper and why? So going back up first, all our hard work, we found out the weight of the vehicle on Earth and the weight of the vehicle on Mars. All right. And in question D, we worked out the pressure that the vehicle exerts on Earth. So how about we find the pressure it exerts on Mars, and then we compare. So the pressure for Mars is, again, force divided by area. But this time, instead of the force being 25,000 newtons, it's only 9,250. Right? Because the gravitational pull on Mars is lower. However, they do have the same area of 1.5 meters squared, which gives a pressure of 6,166 pascals. Whereas from before, the pressure on Earth, we found out that was, what was it, 16,000, yep. So almost 10,000 pascals greater. Okay, and so now let's try to tie that into the underlying physics. So weight force on Mars is less, or the weight force of the rover, right? Let's be specific. The weight force of the rover on Mars is less than on Earth. Yep. The contact area of the rover with the ground is the same in Earth, or on Mars and on Earth. Right, and that's because the rover itself doesn't change. Right, the wheels are the same on Mars and Earth. So we've talked about the force being different and the area being the same. And now how does this relate to pressure, and then therefore how deep it sinks into the soil? So we've done weight force, we've done contact area. Now linking this back to pressure, this means the rover exerts less pressure on Mars. In fact, it's 6,166 pascals compared to Earth, compared to on Earth, which had 16,667 pascals. So we've compared the pressure. And then finally, what does this mean in terms of answering the question? Right, the different depths. So this means the rover will sink further into the ground or into the soil on Earth as its pressure is greater. All right, that's that question done. Just to summarize this one, because I know it's a lot, we first got some calculations done. Right, we worked out the pressure the rover exerts on the soil on Mars, so that we could then clearly see it's a lot less than on Earth. We then talked about the force, the area, and the pressure, comparing Mars and Earth, right? So the weight force was less in Mars than on Earth. However, the contact area was the same, but this still meant that the pressure on Mars was less than on Earth, meaning the rover will sink further into the soil on Earth, right? Or less into the soil on Mars. Whew. Yep, I know, a lot. Time for a quick break. Maybe play a game, glass of water, and then do some more physics. All right, see ya.